For this tutorial, we will be looking at two text-based nodes in LabVIEW, the Formula node and the Mathscript node. The Formula node is a convenient text-based node you can use to perform complicated mathematical operations on the block diagram using the C++ syntax structure. It is most useful for equations that have many variables or are otherwise complicated. The text-based code simplifies the block diagram and increases its readability. Furthermore, you can copy and paste existing code directly into the Formula node rather than recreating it graphically. In addition to text-based equation expressions, the Formula node can accept text-based versions of if statements, while loops, for loops, and do loops, which are familiar to C programmers. These programming elements are similar to what you find in C programming, but are not identical. The Mathscript node implements a similar concept as the Formula node, but with the additional functionality of a full M-file compiler, making it useful as a textual language for signal processing, analysis, and math. Mathscript is generally compatible with M-file script syntax, which is the syntax widely used by alternative technical computing software. Begin by opening a blank VI. From the menu bar, select File, New VI. When I program in LabVIEW, I like to see both the front panel window and the block diagram at the same time, so I'm going to move the windows to where I can see them simultaneously. The Formula node can be found by right-clicking on the block diagram and navigating to Programming, Structures, Formula node. Click and drag to drop the Formula node on the block diagram. Now let's create some inputs and outputs. To do so, simply right-click on the border of the Formula node and select Add Input. We can name this whatever we like. For our example, let's call it X. Now let's repeat this process and create another input named Y. To create an output, we can similarly right-click on the border of the Formula node and select Add Output. We'll name this first one Z1. Repeat this process, and let's create another output named Z2. Next, we'll need to create controls and indicators for each of our inputs and outputs. To create a control, right-click on your input and select Create Control. Notice that the name does not have to be the same as the name of the input. For sake of ease, and for this example, we'll go ahead and name this X. Repeat this and create another control for the input Y. In the same way, we can create indicators for our outputs. Right-click and say Create Indicator. Now place your cursor over the Formula node and click inside to begin typing. Let's put a few statements inside our Formula node to see what it can do. This first statement tests the condition if X times Y is greater than 0. If that statement is true, the statement on the second line will operate. The second statement sets Z1 equal to 3 times x squared minus 2 times y cubed. Notice that I ended this statement with a semicolon. This is generally necessary at the end of statements for the Formula node. However, notice that the first line, the if statement, does not need a semicolon at the end of it. If the first statement is not true, then we'll need to set z1 equal to something else. This third line handles that case. Finally, let's set z2 equal to the hyperbolic sign of z1. Now that we have successfully created a formula node, let's add a while loop around our code so that we can run it continuously to see how the inputs change the outputs. Right-click on the block diagram and navigate to Structures, While Loop. Click and drag the while loop around the code. Let's make sure and add a stop button by right-clicking on the stop terminal and selecting Create Control. We'll also want to add a wait function so that we're not using up all of our memory usage in LabVIEW by running this loop continuously. Right-click on the block diagram and navigate to Timing, Wait. Place the wait somewhere inside the while loop. Then you can right-click on the input terminal and select Create Constant. Let's add a 100 millisecond wait to our loop. Now let's go over to the front panel to see how our program operates. Go ahead and press the Run button. Notice that when the inputs are 0, the outputs are also 0. You can try changing the inputs to see how the outputs change. See if the outputs match up to the formulas inside the formula node. When you are finished, press the stop button.